All right, so in Unit 4, our goal is to be able to convert numbers between binary and decimal, is to be able to use basic mathematics in programming, and then to be able to define what the word assignment means in programming, and then to just practice tracing through some programs because we will be tracing through a wide variety of programs throughout our time in this course. So that's our goal by the end of these lessons: binary, math, and then assignment and tracing. So for those of you that haven't seen binary before or who have maybe just kind of need a little refresher on binary, I want to explain basically where the binary number system comes from. So I've displayed a number up above. This is our normal decimal number system. So that you would read as the number 17,093. And we're going to talk about how the decimal number system functions and then compare it to the binary number system, and hopefully that'll help it make a little bit more sense. So in the decimal number system, we have the ones place, the tens place, the hundreds place, the thousands place, and the 10,000s place. You're all pretty used to this type of system. You've seen it before, and you know that every single digit, so every single number in this system, this ones place here can have a value between 0 and 9. The tens place here can have a value between 0 and 9. And it's the same process as you increase from ones, tens, hundreds, thousands, and 10,000s. But what I bet you haven't really thought about before is really the fact that every one of those places is representing how many 10 to the power of zeros you have. So this is saying that you have 10 to the power of 0, you have 3 of those. 10 to the power of 1, so that's 10, you have 9 of those. So 10 to the power of 0 is really 1. So this is 3 times 1. This 9 right here is 9 times 10. This right here is saying you have 0, well 10 squared is 100, so you have 0 100s. This right here is saying you have 7 1000s. And this right here is saying you have 1 10,000. So really what's happening here is they're taking 10,000, that's your 1, plus, well, the 7 1000s you have, which is 7,000, plus the 0 100s you have, which is 0, plus the 9 10s that you have, that's 90, plus the 3 1s that you have, and they're combining that all together to equal 17,093. So really what that number represents is how many 1s, or 10 to the 0th powers you have, 9s, or 10s, excuse me, how many 10 to the first powers you have, 100s, how many 10 to the second powers you have, and so on and so forth. So that decimal number system, essentially, as I mentioned on the previous slide, each one of these digits can be a value between 0 and 9. There are 10 possibilities, and the decimal number system is what we call base 10. Every single one of these digits represents how many of some base of 10 you have. Now, our binary number system is the exact same concept as the decimal number system, except for every place represents a power of 2. So where the decimal number system represented powers of 10, the binary number system, and binary should be kind of like a bicycle or something like that, but that bi part means 2, means that it is base 2. So I kind of just translated the previous slide and turned it into powers of 2 instead. So if you think about this here, if you look at what I have written down, this first spot here, this here is your how many 1s you have, because 2 to the power of 0 is 1. This second spot here is how many 2s you have, because 2 to the power of 2 is 2. This third spot here, 2 squared, is how many 4s you have. This fifth spot here is how many 8s you have, because that's 2 to the power of 3. And this last spot here is how many powers of 2 to the 4 you have, which is how many 16s you have. So if I were to try and figure out what this number in binary actually represents in our decimal number system, well, what I'm saying is I have 1 times 16, that's this one right here. I have 0 times my number of 8s, 0 times my number of 4s, 1 times my number of 2's, 1 times my number of 1's. So at the end of the day, I would take 16 plus 0 plus 0 plus 2 plus 1. And this number in binary actually represents 19 in our decimal system. So really all binary is a different way of representing a number. And it's the same idea as the decimal number system, but it is just base 2. And now because it is base 2, when we had a base 10 number, we had 9 or 0 through 9, so 10 possibilities for each digit. Now, each one of these digits, because it's base 2, we only need 2 numbers, they will either be 0s and 1s. And for those of you that haven't worked in binary much, the reason this exists is because computers are very, very limited. Computers really can't interpret much. They don't need multiple numeric values thrown at them. Computers can really only read an on or an off switch. So 0s and 1s represent an on or an off switch, and that's why all of our code, the machine code that we have, is written in binary, because computers can only read on and off switches. So that's where this number system comes from. And on the next few slides, we'll practice converting into binary, and we'll practice converting from binary to decimal. So as I mentioned on the previous page, converting binary into decimal, we need to first remember that binary is of base 2. So what we need to do is remember that each one of these digits represents how many of a specific power of 2 we have. And so what I like to do is I go through, I kind of above the number will label, okay, this is the 1 spot, the 2 spot, the 4 spot. So I remember that 2 to the 0th is 1. 2 to the first power is 2. 2 to the second power is 4. 2 to the third power is 8. Then 16, 32, 64, and 128. And you can see I also labeled those on the bottom. And then I go through and I add together where I actually have a 1. So I have 1 times 128, 1 times 64, 1 times 8, 1 times 4, and 1 times 1. And you can see this along the bottom. This should be a 64, so sorry about that. So 128 plus 64 plus 8 plus 4 plus 1. And that in turn adds up to equal 205. So this number in binary, 11001101, is the same as 205 in our decimal number system. So the first thing you should be able to do is convert from binary into our decimal number system. So what I'd like you to do here is I would like you to pause the video and I would like you to practice converting from binary into decimal. So pause the video, work through these 8 problems, and then on the next slide, you can check your knowledge of how you're doing. Can you convert binary into decimal fairly easily? So here I would check your answers, see how yours compare to mine. If you have any issues or you think that one of them might be incorrect, this would be an excellent time to ask a question. I'm not going to walk through all 8 of these. My hope is that if you've got this down, you're good to go. You'll move on to the next slide. And if you are struggling with binary, this is an excellent time to call me over right away and ask if I can walk you through a couple and we can talk about them as you work individually. All right, so the next chunk, and I think this is a little bit more challenging just because it's not as easy as just adding numbers together. You have to do a little bit more thinking as you convert from decimal into binary. So what I like to do when I'm going to convert decimal into binary is I like to kind of list along the side all the powers of 2 that I know are less than the number I currently see. So if I start, I know that I would start with a 1, then 2, 4, 8, 16, 32, 64, and then the next one would be 128. And I know that I don't need that value because that's bigger than my 93 already. So what I do is I kind of start, and it's basically a big math problem to rewrite it into binary. So I know that I'm going to need a 64 in order to start 93. So I know automatically I'm going to need 64. So I kind of put a 1 next to the 64. And then 93 minus 64, well, if I subtract those out, I find that I have 29 remaining. So 93 minus 64 leaves me with 29. And then from here, while I know that I don't need the 32, so that will be represented by a 0, because I only need 29 more. And then from here, I would need 16 because that is less than 29, so I'm going to subtract here. I have 13. I would need the 8 because that is still less than 13, so I subtract the 8 and I get 5 remaining. I do need the 4, I can see that here, so I subtract the 4. I have 1 remaining. I do not need the 2 because I only have 1 remaining, and then I have 1. So I can zoom this out a smidge to finish my math problem there. Subtract the 1, and I'm left with 0. So I can see right along the side that my number is going to include a 64, it will not have a 32, will include a 16, will include an 8, will include a 4, will not include a 2, and will include a 1. So there's my number written in binary. And now a good choice here to check your answers is to go through and add these back together and make sure that they add up to be 93. So I know that this right here, this is a 1 plus this is a 4 plus this is 8 plus 16 plus I have my 64. So just kind of working backwards, I know that 16 plus 64 leaves me with 80. And then if I add the 80 plus 8 plus 4 is 12, so that leaves me with 92. Plus that last one is equal to 93. So I know for a fact that 1011101 is in fact the binary version of the decimal number 93. So again, what I'd like you to do here is I'd like you to take the time to convert these numbers from decimal into binary. So you can use your notebook, take some notes, try these on your own, and then on the next slide you can double check your answers and see how they went. So again, I would do the practice, make sure that you have it down. For most of you, you can do this very, very quickly if you've done binary in the past, but make sure you have a good solid understanding of binary before you move on. All right, so make sure that you check your answers. They are listed here. If you are struggling, again, this is an excellent time to ask a question. That's what I am here for in the classroom. So make sure you ask a question if you are struggling with your conversions. Make sure you understand the relationships between decimal and binary. And once you think you've got a solid understanding of this, you can move on to our next lesson concerning mathematics.